Okay, in this question, we do have a spring attached to a block, and the block is going to be sent along the horizontal surface, and our job is to find out how far it goes before it comes to a complete stop once it's launched by the spring. Now, again, it's a good idea to place the origin at the lowest position, so we'll put the origin right there on the ground, and we see that it will not travel above the ground. It'll travel along the horizontal surface. So our job is to get force normal. And force normal along a horizontal surface is just equal to gravity. So then I take 15, multiply that by 9.8, and we'll get a value of 147 newtons, okay, for the force normal. Okay, now we're ready to determine our energy that's involved with our conservation of energy equation. So then I go, well, are we moving initially? And it's just sitting there. It's next to a spring, so no, it's not moving, so no kinetic energy. Are we above the origin? Again, we're at the origin here, and that's the horizontal surface all along the way, so no gravitational potential energy. Is there any springs attached this time? And the answer is yes. I've got a spring that's right next to that block, so we know there'll be elastic potential energy. So let me give it at least 3 boxes of elastic potential energy. Okay, is there any work done other than the spring? And we look for an applied force, and the answer is no, there's no applied force acting through a distance. So there's no work done. So our beginning is all elastic potential energy. Okay, now the second case is the block somewhere down here along the horizontal. It's not near the spring any longer, so no more spring attached. And it comes to a complete stop. So in our final case, it's not moving, so no kinetic energy. We did not move above or below our origin, so gravitational potential energy is 0. And as already stated, the spring is completely relaxed, and the block of wood or whatever it is now somewhat down the horizontal, so it's not next to it. And we've come to a complete stop. Therefore, we must have some thermal energy. Again, we're sliding on a horizontal surface, so that's our first indication that there could be thermal energy. And I see that there is a coefficient of friction here. So I will give it 4 boxes of thermal energy. So our equation then for the conservation energy is elastic potential energy is equal to thermal energy. Okay, I know that elastic potential energy is 1/2 kx squared, so I do 1/2 950 multiplied by 0.67 squared. And that'll equal my thermal energy, which is force normal mu multiplied by distance. And our force normal is 147. And our mu value is 0.22. And distance d is not known in this question, and that becomes our variable. So one more time, we're using our thermal energy part of the equation to find distance. Okay, and solving for distance, it equals 6.6 meters. And that's how we handle a spring pushing an object, sliding on a horizontal surface, coming to a complete stop.